Good afternoon. Thank you for coming to the presentation. Hi. My name is Ron Singh. I work for Digi International. The presentation today I'm doing is about chip selection and then why a modular approach might be a better for many companies that are here today, particularly for a startup or a new company. So if you've been reading the press of late, you might have heard that there was a bit of a chip shortage going on over the last 12, 15, 18 months. There has been a cataclysmic global chip shortage, which has affected every element or every segment of the manufacturing world, whether you're building cars, consumer goods, medical goods, industrial. It's cost those respective industries millions of dollars in unmade product or unused capacity, or companies that have kept their production going. They have overpaid for chips on the grey market or through franchise distribution because of what's been happening in the marketplace. So yeah, to the point I was just making, prices went through the roof again. I think probably for the last 18 months there have been quarterly, if not every other quarterly, price increases. Those increases have been anywhere between 10 and 20%, given the chip manufacturer. For the first time, I've been in this industry about 30 years, for the first time ever, backlog has been repriced. And that was a huge no-no that nobody ever considered as something would happen. You know, you place your orders out 12, 15 months, and in theory, you place it at a price, and that's the price you pay when it's delivered. Not this time round. It has been common practice that even if you followed the rules or the guidance, whatever you want to call it, and placed your orders going out as far as possible, if they repriced your backlog. They gave you the option to cancel the orders if you didn't want to do that, but you know, most people need their product, so they accepted the price increases, and we're a manufacturer. We had to accept that from many of the chip vendors that we had. So pricing a backlog, that was a huge thing. Lead times went out to over a year and then moved into what is called allocation. If you don't know what allocation is, good for you. But if you don't know what allocation is, it's the very common practice of, this quarter I've got 1 million chips, I've got 2 million chips on demand. I have to allocate the product amongst the customers, and they're going to have to just live with how much I can give them. And allocation has been in full flight for at least the last 15 months. Certainly that's how long we've been living with it. And to that point, under allocation, very few, if any, customers get 100%. Not the guys making servers, not the guys making laptops or mobile phones or cars or industrial, medical. Nobody got 100% of what they needed. I've spent most of the last 15 months being very apologetic on phone calls to customers, telling them why I can only get them, in theory, their drop-dead quantities, but certainly not 100% of what they need. So in desperation, many of those customers, including ourselves, had to turn to the grey market to go and buy the shortfall. There's always product available on the grey market. And honestly, it is not uncommon to have paid 10 or 20 times what the going rate is for a component. So we make a module, for example. There is a PMIC on there from NXP. Normally we'd pay $1.50 for it. We have had to buy those products for $25 just to make our modules, just to keep production going. These foils I'm quite happy to make available to anybody who wants them afterwards. I post them on LinkedIn, so you'll be able to download them. But PPV is a real issue out there. And equally well, a flip side of PPV is that often manufacturers are building up an inventory of hundreds of thousands of dollars, and then they're short of one component, and they cannot get hold of that component. So they've got money tied up in inventory that they can't utilize. And of course, when you get to a situation like this, crime is rife. So we've had many customers, and again, we've been a victim. I'd be a liar if I said we weren't. There are 3 ways you can get scammed. Often there's just a fake website, and there are loads of those going around, and the amount of customers I know personally who have gone onto a website, seen supposedly product available, wired the money, and then guess what? Nothing happens and that site disappears. So always check out Trustpilot if you don't. We've got customers who are buying fake product. So the product's turned up, it's either been old dye or just something completely different inside, and more commonly reclaimed product. So it's the genuine product, it's just been, soldered off a PCB, cleaned up, re-tinned and resold, which sounds like a good idea, but of course you don't know how it was used prior to when you got hold of it. Has it been stretched to its voltage tolerance? Has it been, the innards has been damaged through spiky voltage? If it's flash memory, have some of the sectors been warmed down? So, and I do know customers who have consciously bought second-hand product because the alternative was they couldn't build anything. The semiconductor market continues to grow. You can see, the blue line there is the global line, and it's on track, certainly for this year to increase at about 16%. As we go into next year, there's some anticipation about how that might go. You may have read recently that the Chinese market, in particular consumer goods, laptops, mobile phones, has seen a bit of decline. That might negatively impact next year. But for certain, the electronics industry as a whole, generally up and to the right. And you can see that in the metrics that the key players in the market publish. So the grey line there, for example, is TSMC, globally the largest manufacturer of wafers and semiconductors for third parties, for the fabless companies. But, the green line there is ASML, Dutch company, who makes most of the essential equipment that goes into a fab. And then you can see the yellow is Texas Instruments, the orange is ST Micro, the light green is NXP. It's all going up to the right. The interesting thing to look at, though, are the margins, the gross margins that they publish, and they're largely flat. And the reason is, although sales are going up, they're having to reinvest a lot of their money into building more factories, and that is part of the problem that we're in today. So just a reminder of how we got here. How did we get to this place of there's just not enough components to go around and everyone's suffering? You go back about 15 months or 18 months, there was the China-US trade war, and as a result of that, the Chinese vendors who knew they were going to get blacklisted went out and bought as many chips as they could and stockpiled them. Then COVID hit, and we all went into lockdown. We all started working from home, and there was just a huge demand on IT equipment for us all to be able to be doing home working. God bless it. Initially, the automotive market was close to my heart. Right. Initially, the automotive market was completely depressed because they all thought, we were all in lockdown, nobody was going out and buying a car. So they all cancelled their orders. And the automotive market works on, you probably heard JIT, everything's just in time. They don't hold inventory, it's delivered to just in time to the factory line. So they cancelled their orders thinking nobody was going to buy a car. The chip companies didn't care because they were building for the IT market, which was suddenly in spiky demand. A lack of a mobile workforce, because we were still in lockdown, meant companies started to embrace IoT a lot more. And I'm guessing for many of you in the room, this is the opportunity that you're looking for, right? Because companies have learned from that, and they're all thinking the next time this comes around, they've realized they can't rely on somebody jumping in a white van and driving to the other end of the country to take a reading or check a piece of equipment or so forth. This is the time of IoT, and that sucked up a lot of electronics as well. We were still in lockdown, we couldn't get out, we couldn't go on holiday, so we spent more money on consumer electronics. And some of you with younger kids might remember you couldn't buy a Slack or a, which is it, PlayStations or whichever. Suddenly they're all on long lead times. We came out of lockdown, and nobody wanted to use public transport. So we all ran out and tried to buy a car. Guess what, though? Nobody built any more new cars. So this was a huge problem. We then have a situation where, and I'll come back to this, factories and the fabs and foundries are now running at 80% capacity. Anything over 80% is not good. Anything over 80%, you risk a reduction in yield and you risk excessive wear and tear on the machines. We then had a couple of, what I would say, unexpected events. We had a fire at a fab in Japan, Renesas's fab. Taiwan suffered a very severe drought, which affected TSMC, and they literally were trucking water in. And then Texas had some freezing weather, which then thawed out, and it flooded 3 significant fabs that were over in Texas, TI being one, Samsung being the other, and I think NXP was the third. In each case, those fabs only went offline for about 2 weeks. However, when you take a fab offline, it takes 8 to 12 weeks to reboot it. The nature of a fab is you have to clean all the pipes out, take all the processes back to reset and restart it again. So they lost about a quarter's output, each one of those fabs. Crypto coin was really in vogue, as most of you remember, and so you couldn't buy an NVIDIA GPU or a lot of DRAM, putting more demand on a very exacerbated place. And then the other one to consider, of course, is people. Although we tend to think of these factories as being largely automated, they rely on the presence of very, very skilled workforce. And COVID, again, had an impact on just the number of people and with the right skill set turning up in the factories. But all that exacerbated what was going to happen anyway. And what was going to happen was what we call the semiconductor cycle, right? And this happens every few years and has been as long as I've been in the industry. If you take it, the green line there, as I showed you earlier on, demand for semiconductors just goes up and to the right. From a supply chain point of view, this is how the investment curve from the semiconductor companies works. You make an initial high investment and billions of dollars to build a factory, right? Once you built that, you start running the factory, but there are still running costs maintained. Those go down until the point at which you hit 80% capacity, and then you start to sink money into keeping it maintained again until you reach a point where demand outstrips supply and you've got to make that big investment again. And that's kind of where we are at the moment. And then the cycle repeats itself. This cycle has been going on for years because a fab costs so much money to make, and you can't just add 5 or 10% capacity. It's a very digital thing. You can just build a new factory, but it does cost billions. How this affects prices? Well, you can see that when those first fabs go online, then suddenly supply increases. That has a negative impact on pricing. And then you reach this point here where we are now, where we've outstripped supply, and those companies are making the decisions about some of the investments that needs to be made. Now, if you're a chip company and your factory's sold out and you can jack your prices up every 15% every few months, your incentive to go out and borrow and go into debt to build a new factory, you're going to drag your heels on it, because the minute you do that, you're in debt. So this is where we are at the moment. As a result of that, you've seen maybe the US CHIP Act, where they're pledging 52 billion. You've seen the EU Act, where they're pledging about 40 billion, all to incentivize chip manufacturers to build factories in their region. And that's because there's been an over-reliance in Asia, specifically on Taiwan, for the last 10, 15 years, right? Taiwan today accounts for 26% of the revenue there, right? It's not just the manufacture. There's all the test, packaging, lead frame production that they all hold as well. Overall, today, 64% of semiconductors manufactured come off that island just off the coast of China. That island that currently China is saber-rattling about going into and exerting their dominance on. And I tell you now, if that does happen, I'm going to go sell umbrellas or something, because I don't want to be around for that, right? But it's something to be considered, and it's one of the reasons why the EU and the US is throwing money at building new fabs. The problem they've got is that those fabs take roughly 2 years from breaking ground to going to mass production. It takes a long time. They're small cities. If you ever want to look at some photographs or Google map them, they have to have dedicated water supplies, dedicated electrical supplies, very stable ground, good logistics route because the products have got to go out, but all the various materials have got to get in, and very stable ground because it's a very fine process that can't be prone to tremors and things like that. So there's a lot of investment going on right now. One of the biggest problems you've got is that the wait for equipment. I talked about ASML, which is a Dutch company. There's also a couple of others like Applied Materials, Lam Research, and currently the lead time on their equipment's a year. So even if you broke ground, you've got to make sure you got your orders in time to get the equipment to arrive. And guess why their lead times are long? Because they're waiting for semiconductors. Circle of life. Just a reminder there. So globally, what you've seen in the last 12 months is this move to get off the dependence of Taiwan and build fabs in every other corner of the world to try and make certain that they're not reliant on one geography. And like I said, the whole thing with China, saber rattling at the moment, is making everybody nervous around Taiwan. Making semiconductors, as I mentioned, is not a cheap thing. Typically, a fab will cost you minimum $1 billion, and that's usually an additional building attached to an existing fab. If you're breaking ground on a new fab, $3 to $4 billion, and if you're doing a super fab like TSMC just did, it could be nearing on $9.5 billion. So making fabs require a huge cash investment up front, and as I said, as soon as you go there, you're running to make certain that the fab is running at a reasonable capacity so it's paying for itself. Below 50%, a factory is running at a loss. So at that point, the chip manufacturers tend to drop their trousers on pricing because they want to fill it with orders. Get over that 50% and get as quickly as they can to 70%, where it's largely quite profitable, but they don't want to go over 80% because then they start having negative impacts potentially. Just a couple other things. I've talked about the fabs, which is actually the manufacturing of the wafer and the masking of the die, cutting it. You've still got to think about all the other bits and pieces that go into it, such as the testing, the packaging. And it's amazing over the last year, because we do make some of our own chips, I've watched the bottleneck change throughout the year. First time it was actually getting the die, then it was getting lead frames, then it was getting test capacity. The bottleneck just moves down the process as you go along. And then logistics, shipping has, gone up in cost, container costs has gone up. We've had to, on some instances, like many other companies, switch to air freight because you just couldn't get ship container freight. That's escalated our prices. So there have been plenty of other things that have impacted the cost. Just touch here, and this is as I kind of get into some of the really important things. Hopefully, you will have heard of geometry or node size when it comes to chip manufacture. And also the wafer size, as you can see, you go back to probably when I first entered the industry, it was an 8-inch wafer. Now most of the manufacturing is a 12-inch wafer. There are moves to move to 18, but that presents a whole other bunch of problems. The other thing is the node size. So you'll hear terms like 180 nanometers, 130 nanometers, 90, 65, 40. When you get to about 22 nanometers, those were actually relatively scientific. That was what the size was. The minute you start going below 22 nanometers, you hear 16, 14, 10 nanometers. There's a lot of marketing there. It's actually not at that size, and there are deviations and derivatives of that. But suffice to say, the smaller the geometry, the bigger the wafer, the more chips you get. And the chip manufacturers want to be building the biggest wafers at the smallest geometries to get the biggest amount of chips which they can sell. Customers want to design something in that's going to be around for the longest. And that's where this false matching of expectations meet. Customers would prefer to design something in, depending on the nature of your product, safe in the knowledge that 5, 7, 10 years down the line, you can still buy that, because if you can't, you've got to respin your board. And if it's RF, for example, you've got to recertify it, new ETSI approvals, and so forth. So that is the biggest problem we have is right now the wants of the fabs versus the wants of the customers, because the fabs would rather just continue making large wafers, smallest dies, and never change the process. Every time they change a node size or a wafer size, that's an additional manufacturing cost because it's all resetting up of the tooling. So what should you be looking at today? If I look at this graph here, matched with the key over there, you'll see all the various common sizes of node and where the investment in manufacturing has been made. So if you look at what I call the legacy geometries, 130 to 180 nanometers, they've been going the longest time. Does the laser work? Not really. They've been going the longest time, the year 2000 when I've started this graph. And you can see that as you go up to 2020, there's been no increase in manufacture of these legacy geometries. All the investment has been in the newer waves. We have now today what we call mature nodes, so that's 65 to 90 nanometers. There's still manufacturing go on, and it's still a significant amount of manufacturing going on, but over time you can see it will go the way of legacy. Today, it's terrible on the screen. Today, if you look at sort of the 40 to 65 nanometers, that's what I call the current sweet spot, right? That's where, you know, it's a good place to be speccing your chips for long life designs in industrial, in medical, because those products are going to be around. If you started the design 5 years ago, you know you're good for another 10 years, probably a little bit more before that starts becoming legacy or mature. For future designs, our guidance is looking at 22 nanometers to 28 nanometers is expected to be the sweet spot for the next 10 years. And again, there'll be another 5 to 7 years afterwards while that technology matures and goes legacy. Down here, down at the sub or 16 nanometers and below, this is where, as you can see, a great deal of investment is, but this is a very, very fast-moving market. Most of the people building here are building products for consumer applications, laptop computers, mobile phones, and so forth. So you can pick a chip made here, but chances are it's only got a shelf life of 2 to 5 years. It's the customers are rolling over because they know that the next Wi-Fi generation will be out, or you'll be moving from Bluetooth 4.2 to 5. So they're giving very limited shelf lives because the products that they're going on are being rolled over at least every 2 years, like a mobile phone, like a laptop computer. If you're making a laptop computer, you're not really interested that the component's going to be available 10 years from now. You're banking on your customer base to move to the next version of a laptop. So, given all that background, why might a modular approach be better for you than going chip down? What I tend to say to customers when I speak to them is, what is your end product about? And if you've got an idea, you've got a product in mind, what is your secret sauce? What is your IP behind your product? Is it the electronic hardware design? Is it your design of the PCB? Is that what's valuable to the customer, right? Is it your software development, the way that you integrate your operating system with the drivers and everything else that goes around it, writing your own security system? Or is it the end product, what the end customer experiences, the aesthetics, the GUI? What is the value of the product? I would argue, for many companies I speak to, that the value of their product is not how highly integrated they design a PCB or their choice of components, or even their base software development. It's what the end product looks like to the customer. I talk about things like the opportunity cost. if you bury yourself in the first two segments there, have you missed the opportunity to go do something else? Could your design engineers be working on this bit, which is the bit that's important to you and to your customers and differentiates you from your competitors, rather than sinking all your design effort into there? So opportunity cost. Timing advantage, very simple. If you can go with a modular design, which you can complete in a year, rather than going chip down, which will take 2 years, what is the capital advantage of getting your product out to market earlier, getting there ahead of your customers, in theory being able to command a higher price for it, than trying to go with a chip down design because on paper it might come out as being cheaper. Technology debt. If you go chip down, well, whatever product you design, but particularly if you go chip down, you own that product for its lifetime, right? So if you're designing something that's going into an electronics, automotive environment or automation environment, sorry, I should have said, then it could be that your customers expect you to service that product and make it available for 7, 10, 15 years in their environment. Could be medical as well. So you're responsible for that PCB. If a component goes on it, you've either got to be able to get hold of another version of the PCB or to be able to change your component. On-time NPI, I've never seen anybody in the lifetime I've been doing this turn out a chip-down design on time. There's always something that goes wrong. There's always a respin, right? I'm happy to be proved wrong, but nobody has ever met their own internal timescales in what I've seen. And then there's what I call a modular design naivety. A lot of customers have a belief that that going with a modular design is more expensive than going chip down because they've looked at the bill of materials and compared the two and gone, well, one is $20 and a module is $40. Why would I pay to go that way? Right? They're not looking at the total cost of ownership of going chip down, which is maintaining the product for its entire lifetime and the extended design in cycle. I often talk about the number of components. If I look at a module, which you can buy off the shelf, typically there's a core processor inside, they've added a security element, there's probably an administrator MCU in there which can drop the whole module down to a very low power setting and then wake it up on a certain signal. There'll be all the memories in there, and there'll be a radio perhaps, a Bluetooth, Wi-Fi. And they've all been picked to coexist with each other, and they've all been picked so that they're available for a longer period. They've looked at the manufacturers, they've picked the manufacturers' chips who've said this chip's going to be around for the next 7, 10 years, what have you. They've done all that selection for you. They've then added all the ancillary components, the PMIC, the power, the signal chain, filtering, and so forth, and then all the other components. And if I look at some modules that we produce, one sort of at the low end, which is based on an NXP processor, an IMX6UL, there's 230 components on there. At the higher end, based on an IMX8X, there's 440 components on there. What we've seen with many customers is they'd rather just buy one part number than try to manage that entire bill of materials and source all the components, particularly in this environment, if you go back to some of the things I told you earlier about being able to get 95% of your bill of materials, and then you're short on a few components that you either can't get, so you can't build anything, or you're paying through the nose to get to keep your manufacturing going. We like to think that we offer our customers some sort of scalability. So we offer modules, but we also offer single board computers, and we have partners who, if customers do go to those heady volume heights, can go chip down. The reality that I've seen over the years is customers, when they go with a module, very, very rarely ever go chip down because it's just not worth it. They'll buy hundreds of thousands of modules every year, and they'll spend their engineering time on the next generation of product because the saving in going from a module to chip down just doesn't warrant respinning the board to go chip down. You make a fraction of a saving and you miss out on designing the next product. So our experience is customers tend to just stick with the module and go that route. I've put in some factors here of volumes, but as I said, I've got customers today who are buying hundreds and thousands of modules a year, and I do say to them, surely you're going to go chip down now, and it's not worth it. Our engineers are better employed making the next product. A good modular supplier will always give you alternatives. There'll be some sort of upgradability, whether it's moving to a higher power processor or radios that cover more bands or other features. There'll be some sort of flexibility, maybe having a smaller memory variant because you don't need so much memory for one platform and higher memory on another one, or having Wi-Fi and Bluetooth in one and just Ethernet on another one, all within the same footprint. So this gives an opportunity to reduce risk by not focusing on the time and cost. And then I talked earlier on about RF. One of the biggest problems about employing a module or a design with RF is that you've got to think about the certifications behind it. Bluetooth approvals, SIG approvals, for example, or regional RF approvals are not cheap. If you're going chip down, every time you respin a PCB, you'll have to go through all those approvals again. A good modular supplier is giving you pre-certified modules. And of course, if you are doing all the RF yourself, then you've got to maintain all the test equipment and the measuring equipment that you're using throughout your design cycle. A good vendor will allow you to leverage their economies of scale. So you might be making 100,000 machines a year, and you're able to negotiate with chip vendors to the tune of 100,000 components a year. A module vendor is probably making 1 million units a year, so you get to leverage his purchasing ability with the chip vendors and get the better deal off the back of that. And of course, if you've got multiple platforms or multiple variants in your product, you can simplify your PCB and just swap out the modules that you need. And that's something that somebody like Apple does. Apple don't go chip down on their mobile phones with, say, their radio. They buy a module. It's usually made by someone like Spill or Murata, and it's got a Wi-Fi Bluetooth chip from someone like Broadcom or Qualcomm, and the crystals and some other discretes, and they buy that module and they populate it across their range of platforms. It's not worth them going chip down because, as we all know, they roll over their modules, their models every couple of years. Going back to that total cost of ownership, if you've got a product that's IoT oriented, then you've got to think about the security side of it. Most days, customers are very wary about letting equipment hang off their network because it becomes a security vulnerability. So I've got customers who make emergency lighting, which is all wirelessly connected. They need to be able to monitor that, but no end customer, like a hospital or this building here, wants that hanging off their network because it's a potential vulnerability. So they have to do their own wireless connectivity, and then they have to build in their own security framework around that. So if you're going with an IoT design, try and pick a vendor that's giving you some element of that as well, ideally over-the-air upgradable. You'd be surprised, and I'm going to put up some of our customers around Europe here who uses modules. Our two biggest growth areas in Europe today are EV charging, driven by the reduction in CO2 and the mass rollout of EV vehicles. Another big market for us is solar panels, solar panel farms, the management of the panel and the tracking with the sun. And, suffice to say, there's been huge investment in this ever since Ukraine was invaded by Russia, and there's been this move to get even further away from oil and gas, as well as looking to renewables. The EU has a target to have an EV charging station every 60 kilometers in due course in Europe, and it must be 100% powered by renewables. So these customers are trying to get their products out to market quickly. Taking 24 months to do a chip-down design just doesn't cut it. They've gone with a module to get the product out quickly. I talked about emergency lighting already, but we've got customers who do like the city bike schemes in Paris and a couple of the cities. They go with a module because they just want to get the product out simply. we're very big in medical, and that's a slightly different reason. They're building equipment that's going into hospitals. They're building equipment that's going into residential or assisted living. Those products are going to sit there for 15 years. They don't want to have to rip them out in 5 years because the manufacturer can't easily replace the electronics. When we release a module, we guarantee it for 10 years minimum. In truth, we've got modules which are 20 years old we're still making as long as we can still source a silicon or do a quick redesign and keep it going. We're Digi, as I mentioned. We make a series of system-on modules which are based on a processor design, as I mentioned earlier, with all the memories and radios, security element, and power administration. We also make XP. You might recognize XP as this wireless family with the chamfered corners. We do a series of form factors. That's the pin-through hole that everyone recognizes because of the chamfered corners, though. We do surface mount and now a new micro surface mount. The beauty of XP is that whichever frequency band you go for, sub-gigahertz for long range, 868 megahertz in Europe, or short range, 2.4 gig, and on 2.4 you might go Zigbee, you might go 802.15.4, you might go cellular. Whichever you pick, the pin out and the footprint is always the same. So you can lay out your PCB for one pin out and you can swap modules. So we've got customers, for example, making robot lawnmowers, and they're shipping them all around the world, and they're all wirelessly connected. They lay out for that. It goes to Australia. It has a certain 900 meg module that's certified for Australia. It goes to Japan, same thing. It stays in Europe, they go 868. They're going for a small campus like a golf course or something where they've got multiple stations, they'll go 2.4 gig. They can just lay out their PCB and populate it with the modulars they require. So that's us. Thank you. I managed to stay on time. Thumbs up there. Thank you. I'm Ron Singh. I do this presentation, and I will post this on LinkedIn. You can find me there. I do a regular presentation. I call it Chipageddon for obvious reasons. I update it every month. I found it useful in my sales team being able to speak not to engineers, not to purchasers because they've got their fingers on the pulse, but often the people behind them, the financial backers, the C-level staff who don't understand why things aren't being built because they don't understand the things that I've just explained. So I often say, just push this presentation to them and hopefully they'll get the message. So I update it every month. There'll be a new one coming out this month as well. So thank you all very much for your time. Really appreciate it. We have a booth out there. Digi has a booth. And I'm also got a booth with our partners, Solid State Supplies, which is right at the front of the auditorium. So thanks again for your time. Have a good rest of your day.